This is for the camera.
Oh, gosh, they showed up.
They made it.
Can't believe it.
Surprisingly.
Tamam, çalıştı abi. I think we are full. Good.
All right.
I think we can start now.
All right.
Hi. This is about a rig, quite unusual. It's called the DX FT8. So let me show you here. It's a very small tablet transceiver with 7 bands to carry around for FT8, only FT8. My name is Barbara Sasaroglu. Everyone knows me as Barb. My call sign is Whiskey Bravo 2 Charlie Bravo Alpha. My friend is
Hi, I'm Charlie.
Charlie.
W5BAA. Thank you for being here and showing up. Great. Well, how many of you guys and ladies do FT8? Oh, good. Have any of you gotten one of our boards yet? Oh, we got a good prospect here. Great, thank you. Great, good. Why FT8? Well, it's quite popular. Why do you guys use FT8? Any ideas? Why do you use it? Why?
I use it because I live in a townhouse with a very small backyard and am rather antenna limited.
Yes.
So I can do a lot with a small antenna and not a lot of power.
Okay. Any other motivations for using FT8?
Yes, nearly the same situation, and QRP, and it's portable. I can run up on a hill, and let's run.
Yeah. I'll have to admit the reason I like it is because I'm very lazy. I can turn it off, turn it on, get it synced, and go off and do something else and come back and see who's received me. And I get instant gratification because I can see where my signal's being reported on PSK Reporter. So I have to admit. It is quite popular. Like we've already talked about, it is easy to operate. Most operators are pretty well behaved, but there's some pretty not nasty people, but not well behaved. And I found this on here, and that's one of my favorite cartoon characters from my childhood. But it's turned out to be quite a scrum, if you may have noticed. These are my perceptions. You may have a different viewpoint. But I think on today's band, most of the traffic is automated. That's my feeling. And also I noticed that you have people calling CQ in both the even slots and the odd slots. And this is our agenda for the presentation today. We've sort of talked about FT8. Looks like everybody is familiar with it. And we have some design objectives that we want to present to you and look at the alternatives out there on the market. And we're going to talk a little bit about how we evolve this design. This is probably the 3rd or 4th year of my working on this software. And I did the software, Barb did the hardware. And we're going to talk about the operating, how you operate it. And we're going to talk a little bit more about FTA traffic handling. Barb?
So we started with this project design objectives. So it should be small size, self-contained with internal battery so that we can carry easily all over the place. Powered and charged from 5-volt standard USB wall charger because everyone has one. No mouse or keyboard required, just touch screen operation. and also ultimate portability for backbacking SOTA POTA, so it had to be small. RFPA can withstand severe SWR conditions and accidents of antennas, because if you operate on a different condition areas, you always get some kind of mismatch with antenna or so, and you don't want to blow a MOSFET. So we'll come to that. We didn't use any MOSFET on the PA. Flexibility on calls such as POTA, FOTA, free text, and airport security friendly. This is very important. I had a lot of airport incidents. So this is me operating in a sailboat in Turkey last year. This is all set up that I carried out. I did 47 contacts very easily on FT8. So what is the alternative? We carry a laptop, most probably 13-inch, so keyboard, mouse, 100 clock speed, and all these things, lots of cables, we don't want to carry those with DX FT8. Charlie, you go with the story.
Okay. I got into SDR to go about over 10 years ago. And you may recognize one or two of the names there. Case Callan has taken care of kitting the hardware for us. Milt Cram built a very nice PSK transceiver almost 15 years ago, W5BAA, and he got me started. He took me under his wing and sort of got me into the coding game. And I did a project back then, the SDR to go, which was a compact sideband transceiver. And Case kitted it up, and we sold a number of them. I then got into doing the FT8, and I sent a working board to Barb just to get his interest up, and he bit just like a fish on a line. Great. Next slide.
Now I'm going to talk about the hardware. This will be a little bit technical, so questions are welcome if you stop. So this is DX FT8 pocket terminal RF board. So we have two boards, DX FT8. One is the Brains STM32F746 Discovery board. On top of that, this RF board fits in, and it becomes a 7-band transceiver afterwards. Now, let's advance. So this is the STM32F746 Discovery board. This is manufactured with ST Micro. It's a very, very good board. It has audio codec in it. Everything you need to create a computer is on it. And the beauty of this thing is it's pretty cheap. In US, it was $56 plus shipment. Now with the tariffs, it's a different story. But yeah, it is still affordable. So this has quad SPI flash memory, as you can see, STM RAM, which is 320 kilobyte accessible. Very good codec, 48 kilobit per second. I mean, if you want to build this thing one by one, it will be a couple of hundreds of dollars, I guess. So we chose this as the digital interface and computing power. So this is with Charlie's beautiful firmware, we are using only 33% of the whole flash memory, so many things can still go into this thing. But on the RAM, there's a lot of RAM usage, 82%. Charlie will go into that detail in the firmware explanation.
Yeah, we're in the danger zone here, where if you go much further, it's going to probably maybe have some halts and some not so nice operation.
Now, so this is the transceiver board where all the RF stuff is happening. So this is the block diagram. I'll start with the antenna. First walk you through here, and then we'll come down. So from the antenna, we go into a low-pass filter. There's two low-pass filters here. One goes to through the lower bands, which is 20 meter, 30 meter, 40 meter. The other one is 17, 15, 12, and 10 meters. So we select this with a relay switching, whichever band we are going to use. And then afterwards, we have a LNA preamp that is with BF998. This is a dual gate MOSFET. It's very popular, but unfortunately, it's obsolete now. I don't know why, because it's a very good MOSFET. And afterwards, a BFR93. This amplifies the whole thing. And it goes afterwards to a Taylor detector type quadrature sampling detector, which is very famous. If you are familiar with STR, all of you will know this chip. So I got some criticism why putting an amplifier before the Taylor detector, because it's already very sensitive. But the problem is I put a cross limiting diode, and diode kind of limits and affects the sensitivity. To get that gain, I put a preamp before that, and we are getting like minus 110 dBm sensitivity out of it. And then afterwards, you have the AF preamp and decoding, which is the very famous chip again, 6542. And then I give the in-phase and quadrature signals to Charlie. He processes and does a perfect SSB signal. So now from the low pass, we go into on the transmit side, we have the famous SI5351 PLL VFO. So STM signal comes here. This is not SSB, this is FSK. So what we are doing is we are preparing the audio signal of the FT8 signal, let's say, it's 1500 Hertz, and we are adding it to the base frequency of that signal. So it becomes USB automatically, so it becomes FSK. And then this is amplified with a ACT244 octal buffer. That's it. It's a TTL chip octal buffer. There is one thing here as a trick. I'm not driving this with 5 volts, but 6.5 volts. So everyone will say that, oops, it's more than 5 volts. Actually, this chip can be powered up to 11 volts. Nothing happens. That's an interesting part of it. So with that, you get close to 1 watt on 20 meters. Of course, with the bands, it dies out if you go high up. But we are getting almost 500 milliwatts on 10 meters. So it's more than enough for FT8. And then it goes into a bifiller transformer from mini circuits. This acts like an auto transformer. So it multiplies the signal and it goes to low pass filter and goes. One thing I missed here, to generate the in-phase and quadrature signals, there's 2 methods. One is to use the SI5351 in phase mode to create both signals. But in this one, I chose a different method because I saw that sometimes you have to adjust it. It's not perfectly 90 degrees or 180 degrees. So I put a monostable multivariator here. So I divide it. So let's say 14 meters. For 14 meters, I'm producing a 56 megahertz signal and dividing into 4. When you do that, you automatically give the I and Q signals to this chip. So you don't have to deal with the balance or anything like that. It's already balanced. Perfect.
Excuse me, on that bipolar transformer, is that just impedance matching essentially?
It's more than that actually. It's a bipolar in an auto transformer, so it multiplies by 4 the signal. So I'm increasing the amplitude with that. That's playing a good part. Why this transformer? You can wind it with like FT37 or FT43 types toroids also, but this is very efficient and a high Q transformer, that's why. So this is the transmitter schematic. So here you can see the boost supply that I was talking about. We enter 5 volts, you get 6.5 volts. This is a switching supply, and everyone will say that, oh, switching supply in a rig. But this is active only on transmit, so it doesn't affect RX. So this goes, okay, this is SI5351 as you see. This goes into the power amplifier, which is our TTL logic chip, the octal buffer. And then it goes from here with a, we isolate the signal, only AC, to the transformer. And from the transformer, it goes all the way to the band select relay, which selects the low pass and high pass filters. So this is, and we are using a TCXO, a thermal controlled crystal oscillator. The beauty of this thing is it doesn't drift. You don't have to adjust anything. Spot on works without any frequency adjustment. This is the receiver side. So in the receiver side, the signal comes here from this RF, from the LPF here. This is TX RX switch. So when we are transmitting, this blocks the signal, so nothing comes to the receiver. When we are receiving, it opens up the path, so the RF comes in. So as you can see, this is the limiting diode for any surge. This kind of affects the sensitivity. Because of that, I added this section, which is a classic RF LNA section with the, what do you call, the BF998 dual gate power MOSFET. After that, yeah, we go into the 3253 Tailoi QSD, and from here we get the signals in phase quadrature, and then here you see in phase out, quadrature out, that goes all the way to the processing board. Here we have a little filter just to filter the 5 volts, and that's it. And this is the famous input 4 times the signal and get 2 in phase and quadrature signal for this. I use that just to make it perfectly 90 degrees in phase with each other. This is the battery management system in the latest version of the board. So this is an interesting chip. This chip is acting like a battery management system chip. So it routes the charge and discharge, at the same time controls the output, and we have 4 LEDs that's showing the battery level. We could have shown in the display, but this is more, how can I say, getting your attention type of system because you see that, oh, LEDs are going down, so battery is dying. This is the 5 volt USB input. It goes to the input of the battery management system. Also, we have a switching supply here. When you supply 12 volts, it lowers it to 5 volts, and then again you can supply the rig and the battery charging. This is for the 3.3 volts needed, and this is it basically. And this is, we have an RTC chip, real-time clock. This is only for recording the QSO time on the SD card. We are not using this to sync the FT8 signal. Charlie will come to that. He devised a very clever method. He does it with the firmware, not anything like GPS or anything else. And this is the interface of it. So where these blocks on the RF boards, as you can see, RX circuit is the most complicated. It's here. This is the TX circuit. We have the TX boost here. This is real-time clock. This is all battery management and power input system. Here goes, and this is the power input. So the whole board is aligned like that. We have two switches, one for power input on-off, the other one for RF power select. You can select low power or high power. Low power is basically half the high power, what you get from it. So what else we can do with DX FT8 project future hardware? I have some plans to implement. A 6-meter band will be a good coverage and get 8 bands with this ring, because 6-meter antennas are small to carry around and etc. One thing I'm working on is increasing the power output from sub 1 watts to around 3 watts with a miniature Class D MOSFET PA. But this MOSFET will be again kind of TTL chip. It's not like a MOSFET, so it will be still protected. Replacing the dual gate MOSFET LNA with MMIC type LNA and adding a manual antenna tuner. This will be pretty good for portable conditions. So it's up to you, Charlie. Do you want this to advance, or I can advance? Don't worry,
Why don't you
go.
advance it? All right, next slide.
Next slide.
Let's see, we're going to talk about some of the origins, some of the guts of it. I've got a flow chart that's probably out of date, and Barb's going to talk to you about how to actually operate it. Next slide. I'm not really a programmer, but I've learned to program in a way. The key to my success is I plagiarize. I found a lot of good software out there, and so I love to cut and paste. I did find a good source for the FT8 decoding, a fellow by the name of Carlos Goba, who lives in, I think, Latvia. By the way, Carlos is the name for Charles in the Latvian language. And we corresponded several times, and he was most supportive of our using his code for doing the FT8 modulation and demodulation. Next slide. Here's a block diagram. Barb has talked about his halo detector, which works quite well, by the way. And here in the audio codec, I chose an offset method for decoding, where I offset the local oscillator frequency by 10 kc. And that lets us do the filtering at 10 kc, and you'll see why that works to our advantage. And then we do the upper sideband and lower sideband separation. Next slide. And here's what I'm really happy about. This is a spectrum representation of the output from the halo detector, and you'll see the FT8 signals here around up above 10 kc. And what that does, I don't know, have any of you done an SDR radio or tried to do the software in it? Has anyone? Well, usually you end up with a lot of garbage down here that's really hard to get away from. If you use this method and then bring it down to baseband, you'll notice there's no garbage down here. Next slide. And in fact, this is a blow-up of it, and this is something I'm quite proud of, in that you don't have any garbage down there. And this shows the upper sideband selection. This is lower sideband. So we've got really good sideband suppression, because here's all your FT8 systems, and here's just a bunch of noise. Next slide. And for the processing, we're processing at 32 kilocycles. We decimate by 5 to get it down to a 6,400 bytes per second sample rate. And that gives us the ability to have a fast Fourier transform to do our frequency detection. And we actually are detecting frequencies at about 3.125 hertz. Anyway, that's all the guts of the data processing. Once we get the fast Fourier transforms, those go into the software that does the decoding of the 8 frequency bits of FT8. Is everyone sort of familiar with 8-bit words and things like that? Of course, that's where FT8 gets its name from, in that it's looking at 8 bits. And that allows us to store the fast Fourier transforms so we can decode them.
Yeah.
And also it drives the waterfall display. Next slide. What was I was doing here? Oh, okay. Okay. Then things get really interesting in that you decode the traffic. And of course, we display the messages. You can select a message that you want to respond to. And there you have the human loop, to where that the messages are displayed. You, the user, looks at it, selects one, touches it, and then the software takes over and composes the messages and puts them out on the right time slots. Once we get the messages generated, then we queue them up for transmission. We do display the messages that you are transmitting as they go along. Here again, we're using the 5351 to convert the tones of the message into distinct RF frequencies, and it goes out through Barb's amplifier. In part of trying to figure out how to generate the messages and get them put out in the right queue, I did a lot of study of what you want to do at each time slot. Of course, FT8 has a scheme where a time slot is 15 seconds long, and that lets you essentially transmit 13 characters. So anyway, it's hard to see this slide, but I went through a lot of this agony trying to figure out what to do next. And the previous slide was where you select a station you want to call, and I call that arbitrarily the QSO mode. We have another mode that I call the beacon mode, where it puts out a CQ every 30 seconds until someone responds. Next slide. I noticed that there was a lot of hoopla about having a very accurate time clock on your PC. And I didn't really want to go through trying to get a GPS receiver and actually have it working fast enough so you could sync for FT8. And I found that if you'll watch the signals on the waterfall and simply touch when you see everybody quit transmitting, you can sync it manually. So I think it's a myth that you need a real accurate clock on your computer to do FT8. And I found on some of my versions and I'm going to be sort of naughty here. I noticed that some of our older users couldn't really see well enough to know when to touch the synchronize button. So I put a little bit of automation that it watches the signals, and where's an example? Here it is, you touch it.
Here, I guess, yeah.
And finally the software realizes, hey, everybody shut up. It's now time to sync the FT8, and it works just fine. All right. And Barb, you're wrong.
Okay. Wait. So this is the screen of tune screen, we call it, but it's like a configuration screen. And here we added CQ, SODA, PODA, and QRP kind of buttons. When you choose that, the rig goes into calling CQ, SODA, and your call sign, etc. You can see the PODA here as an example. So literally it can be used for SODA, PODA, QRP. Also, you have free 1, free 2, so you can call anything. It's like I'm calling Europe, CQ EU, or CQ DX, or anything you want to write, CQ Japan. So operating DX FT8, I'm going to talk a bit operating DX FT8 now. It's a little bit different than WSJTX, but not that much. So when you turn on the rig, this is what you see. You get this splash screen. So hardware, firmware version, our call signs, and which kind of board it's supporting at this moment. We started with a 5-band board, and then 5-band wasn't enough. We went to 7-band board. So this same firmware can be used for 5-band and 7-band board, whichever you want to build. It automatically detects it. Here you have your call, your own call, and here you have the 4 digits of your maiden grid locator, which is stored as a setup in your SD card. We'll come to that. So this is the receive signal, screen of DX FT8. So we have the waterfall here. If you touch the waterfall, you can move offset frequency. So this white line is the time sync line. When you use the sync button, when you sync, it shows you your baseline here. So decoded FT8 messages, similar to WSJTX monitor screen, is here. And anything you are sending or conversing with the other station goes into here, in this part of the screen. This is your band frequency. This is your offset. So FT8 can go from 500 to 3500. So you can move it here with these 2 buttons. These buttons are our control buttons at the end, which are touchscreen buttons. Here you have your UTC, RTC time. This will be used to record your QSO time when the QSO is accomplished, and this is the time for it. So I'll go through fast on the buttons here. So this is clear button, which is speaks for itself. When you touch it, it clears screen. This is QSO beacon button. In the QSO mode, you have to choose the station you are going to QSO with. So these guys are calling CQ. If you press one of them, this goes into the queue here, and the rig automatically calls CQ to the station you chose. And it goes like that. In the beacon mode, you press this once. Now the rig calls CQ every 30 seconds, and if a station answers, automatically goes in a QSO mode. So this is a cheat mode. You can leave the rig and you can have your beer while you get QSOs, basically. Tune is, as we are going to come to it, it is tune, but it's a configuration page. It is similar to WSJTX tune. If you want to tune or send a signal, you go to that page, but it does more than that. We'll come to that. Receive indicator. This is the receive indicator. Either is receive or fixed. Actually, Charlie, you can explain this better than me. In the receive. And fixed is the transmit frequency can be fixed, right? If you choose fixed, it stays at 1500 hertz. You don't follow, like in WSJTX, the QSO station's frequency. It stays at 1500. When you choose received, it follows the converse stations or QSO station's frequency and transmits in that frequency. Sync, as Charlie explained, you press sync, it becomes red, and it waits to sync. When it baseline syncs with all the stations stop transmitting, it becomes blue again, then you synced. This is gain. So by minus and plus, you can adjust the receive gain. If it's too many interference QRM, this you can drop the gain. Or if your antenna doesn't receive that good, you can increase the gain with this gain. So this is the basic screen. Now I'm going to pass to... Okay, this is the tune screen that we talked about. So it is the configuration screen at the same time. What we are doing, we adjust the hours, minutes, and seconds of the UTC clock, which is the real-time clock's clock. Also days, months, and years of it. You set it, and then you can see here, which will be used for your QSO recording and logging. Here you can change bands, bands down, bands up. Here again the frequency. After you change band, you save it. And at the same time, there's a transmit, so you can transmit a constant signal so that if you have a tuner or any other purpose of measuring, you can use this. Also, in the newest firmware, as I said, oh, by the way, some of the hams wanted login on and off. They don't want to log all the time. Actually, the rig logs automatically. You don't have to do anything. So this turns on and off the automatic logging. If you turn off, you do the QSO, it doesn't log. So you have certain buttons for certain conditions, like CQ, it just calls in CQ, doesn't add anything. If you choose soda, it adds soda in the CQ call. So it becomes CQ soda, your call sign, your maiden grid. If you add POTA, it goes POTA for POTA QRP, CQ, QRP, and then your call sign. This is very attractive because people answer you more. I found that. So free 1, free 2, you set up those in your configuration file in SD card. So as I said, it can be anything, 13 characters, anything. So you can write whatever the rig transmits that in the CQ calling. The bands are here, as we talked about. You save the bands. Transmit is here. So basically that's it. On that, now it's Charlie, traffic handling.
Next slide. I did quite a bit of study of FT8 traffic. I found a nice program that would decode FT8 signals, and I could save them off to an Excel spreadsheet. And so I spent a lot of time just analyzing the traffic to get a feel of what I needed to do to actually have QSOs. I made a point of not trying to mimic what WJST does. I felt I needed to understand what the basic traffic is on my own so I could get this in my head. So I just said, okay, I want to be able to pick a call and call them. And another mode I wanted to support was doing beaconing or sending CQ. Just keep it simple. I'm an old man. Stari mush. Anyway, this is an example of how we handle traffic in the QSO mode. You'll notice that KI5LSU is calling CQ. I had selected them. We have to wait our turn because if you try to transmit in the very next mode, the software is going to be out of sync with the rest of the FT8 world. And so there you see we finally are giving the guy a call. He responds back in the next FT8 time slot. Then I respond to give him his signal report. Then I finally give him a all finished clear by sending him, he sends me his all clear sign. Then I respond to his, and we finally sign off. So I imagine you guys are familiar with that. Next slide. And this is an example of what we do in the beacon mode. You can see that I continuously call CQ every 30 seconds. You'll see the time of the slot there on the left-hand side. And then finally someone calls us back, and then we get into the normal FT8 sequencing on the slots. Next slide. And we provide ADIF logging. You're probably familiar with this format. I think this is the standard throwdown slot for FT8 logging. Next slide. Here's my final conclusions. Everything the rig works, and we're happy with that. We do well when the other stations are well behaved. And what I showed you in the previous slides is what I call well-behaved operation. But you may have noticed that all operation is not well-behaved. Has anyone noticed that? Yeah.
The well-behaved, not behaved comes like, there's a sequence, right? When WSJTX start with CQ and then it follows automatically. But sometimes we get impatient and we send a couple of times manually other stuff, thinking that the other station didn't hear. So that breaks the sequence actually, and any rig that automatically works, like Beacon, gets confused because now it sent already the RR73 and the other guy is sending another CQ maybe. So that's the thing, yeah.
My perception, as I said before, I think most of the traffic on FT8 is automated in some way, whether if you're in the QSO mode or beacon mode. There are a number of what I call naughty stations, and Barb has talked about that. When you're trying to lay out the FT8 software, dealing with the naughty stations is most difficult because there's a lot of variability in the naughty behavior. And we have a few people in America that are really naughty and that they want to run very high power on FT8, which I don't think is a nice thing to do. But they're there. In fact, I noticed that when I look at the audio spectrum coming out of Barb's receiver, that most time FT8 signals are about 40 to 50 dB above the noise level. Have you all noticed that? Yeah. Also, I think people like to operate FT8 in different ways. They have different goals. They want to do SOTA, they want to do contests. So my perception, there's not a real firm consensus on how to operate an FT8. Also, as part of our project, we got a lot of good feedback from our users, and quite truthfully, when Barb and I started this, we were quite naive on FT8 operation, and we've learned a lot about it from the project. Next slide. If you're interested in this topic about what I say is a jungle out there, that's actually, if you get a copy of the presentation, that's a website. The fellow wrote a real interesting article on that topic. You might enjoy it. I did. Next slide. And this is just a example of what I call naughty and nice operation. Here on the nice side, we go through the regular exchange where within about 5 to 6 time slots, the two sides conclude a QSO. But you'll get, in some cases, for whatever reason, someone will continue to call and occupy the slot repeatedly. And the way I solved that problem is once I saw someone calling us 5 times, I just cut them off, quit listening to them, and go find someone else to converse with.
Yeah, because it's very, it's obvious that they don't hear us anymore, so they are sending more and more, so there's no point on insisting on that guy. You go to the next guy.
Next slide. I copied this from one of the presentations that was made at another convention. If you want to, once you get the presentation, you can try to go through here, but this is sort of the normal flow chart for just a very standard QSO. If you're talking about one where you're having to deal with multiple calls by someone who's not so nice, it really gets horrendous on trying to plot that out. I don't know, does anyone still use flowcharts when they do programming anymore? I did back in the 60s when I started to learn. So it's good to know that people still do that. Next slide. Okay, this is really an important slide. We do have the source code is all open on 2 different sites. Barb has it on his site, and we've got a very good, a real programmer helping us. He's really saved our bacon on this project. If it hadn't been for him, we couldn't have advanced the firmware very well because it had some bad habits that he fixed for us. And that's Paul Winwood, G8KIG. Of course, I'd like to thank Carlos for contributing his FT8 software. Like I said, Paul has been a real jewel on getting our software cleaned up. We had very good input from one of our users that did a complete SOTA-POTA solution for us, so we could just copy that into the firmware. And also a real success to our thing is Case Talon, who lives close to me, who's taking care of getting the boards manufactured, shipping them out, and that's really an important job, and it's not an easy job. All right? Oh, okay. Got something new to show, and now we're just going to, let's go ahead and turn everything on.
Yeah.
Hopefully this will work.
Wait.
Now, Barb, what I'm going to do is put it in beacon mode, and then it'll be up to you to respond.
Okay.
It takes a while for everything to get cranked up.
You did the beacon, right?
Mm-hmm.
Yeah. Let me do it like that also, so you guys can see.
You
So you
can't
guys
see
can
it.
see Charlie's
Okay,
coming
there you
here
are.
now.
All right, right.
Yeah, yeah.
Good.
I have to sync you though.
You can see the transmit signal here.
Yeah.
There. Okay. And there, I've got it set up so that you've got online monitoring of your own signal. So if you're sending out stuff that can be decoded, you'll see it here on the left-hand pane. Okay, it's all up to you, Barb.
I'll put it in beacon.
Yeah, put it. Yeah, okay. No.
Okay.
Next time I come by.
Okay. Hopefully I'll receive you.
Yeah.
Yeah, I
Did
got
you see me?
I
Okay,
got you.
touch it. Okay. Down there to
Now we
very,
are going to do
down
a
there to very white
yeah,
is the,
pseudo QSO between us.
that's the message queued up to transmit. Gosh, I hope this works, Barb. It has to wait for the right slot.
Yes.
Oh, we forgot to sync.
You forgot to sing?
You
No,
forgot
I
to
did.
sync.
I
Okay.
did.
Okay.
I did. Did I? Can I sing? There you go. Yeah. It was waiting for the slot, I guess.
Aha! He called me.
Yeah.
All the way from New Jersey. Can you believe that?
New Jersey to Texas.
What I did is put the map here so that your location is shown as a green dot. And then as you actually complete calls, your target station is located with a red dot.
Yeah, the QSO is done. I recorded you.
It actually works.
That's it. It works. So this is Charlie's new rig.
And
there's
there's Barb's red dot
Yeah.
showing up there. Well, that's all, folks.
Yeah. Thank you.
One
If you-
question from one of my viewers
Yeah.
about future availability of kits or even
Yeah, actually.
ready units.
Yeah, a friend of mine, us was doing Keystel and this, but he has a bit of a problem now. And the other thing is, we have a problem in US, which is called tariffs. So the prices went a bit up. So we stopped kitting because the viability is not there. So hopefully we will be kitting this in the future. What we are doing is we are kitting only the RF board and the related parts. The other board, which is the display board, the controller, anyone can order from anywhere. So with that, they built their rig because it's not viable to get that and sand again.
Thank you.
Yeah. So this is the QR code for the open source site. You can scan with your phone, you can get it.
Yes, sir.
The whole project is open
Say it again?
source. You can build your own if you want.
A board?
A boost. Do you have a boost?
Oh, no.
No. No, this is not a product that we are selling. We are seldomly doing it for fun as kids to make a community so that the whole community actually helped us to develop also this. So it's a going, wish someone pick it up and do it.
Sir?
You're relying on other signals on the band to synchronize. What happens if the band is dead and you've come up initially?
You have to wait until they show up.
I guess we
I'm a big believer in
What's that?
etiquette, in that I didn't want to create a radio that just blathers. So I
Yeah.
wanted to say, okay, if you hear somebody and you've got something to say to them, then you transmit. And really, that's the basis of Ethernet networking protocol, by the way.
I mean, you can drop down to 40 or 20 where there's always something going on.
Yeah.
There.
Yeah.
Yeah, that's a good technique
Well,
because
if you can't hear anything on 40 or 20, something's wrong.
yeah,
Oh, yeah. Then something's wrong. Yeah.
good point.
20 is generally the best band, yeah, to sync anything.
What's the power requirements?
What's that?
Power requirements.
Power requirement. I mean, how much power this for this?
Yeah, I can answer
QRP. You do it, yeah.
No.
Consuming energy.
Oh,
Yeah.
okay.
On receive, it's about 700 milliamps. Then on transmit, it goes up to about 1,200 milliamps at 5 volts.
Calculated for 30 seconds. So you can do a question for 5 hours with a little power.
Yeah, with 3 amp battery, I'm getting easily 3 hours continuous with it. Yeah, with the battery that's inside. Yeah.
Okay. All right. Well, thank you all for showing up.
Thank you. Yeah.
You have a mailing list or something like that?
No, we don't, because we don't know when we are going to start kitting again. So we are kind